In this video, we're going to be discussing the structure of alkanes. Alkanes are hydrocarbons, meaning that they contain hydrogen and carbon, and they contain only single bonds. Simple examples include methane, ethane, and propane. We'll discuss how to name these types of alkanes or hydrocarbons in a future lecture. Right now, we're going to focus on their structure. They tend to be of low reactivity, and we also say that they are saturated in that they have the maximum number of bonded hydrogens per carbon that is possible to have in an organic compound. This concept might be best understood by looking at the opposite, which is unsaturated. Unsaturated hydrocarbons have a lower hydrogen to carbon ratio due to the pi bonds. These can be double or triple bonds. For example, let's look at a 2-carbon hydrocarbon that has a pi bond. This molecule is called ethene, and because of the pi bond between the carbons, it has 2 less hydrogens than the analogous saturated 2-carbon organic molecule ethane. In other words, for every pi bond that we add to an organic molecule, we lose 2 hydrogens. Each pi bond that's added to a hydrocarbon, resulting in the loss of 2 hydrogens, is called an element of unsaturation. Ethene has 1 element of unsaturation. Take a moment now and try to draw a 3-carbon hydrocarbon with a single element of unsaturation. Pause the video and restart once you have your drawing. A 3-carbon hydrocarbon with a single element of unsaturation looks like this. It's called propene. Now take a moment, pause the video, and determine its molecular formula. The molecular formula of propene is C3H6. Again, 2 hydrogens per carbon. How does this compare to the molecular formula of propane? Propane has a molecular formula of C3H8, or 2.67 hydrogens per carbon. Again, more hydrogens per carbon than the analogous 3-carbon unsaturated hydrocarbon. We can use these examples to come up with a generalized molecular formula of an alkane. Looking at the examples of the saturated hydrocarbons above, we see that 1 carbon will have 4 hydrogens. For 2 carbons, we add 2 hydrogens per that new carbon to give us a total of 6 hydrogens. And when we have 3 carbons, we have 8 hydrogens. We can generalize this by saying the general molecular formula of an alkane that is fully saturated will have the molecular formula of CnH2n plus 2. In other words, twice as many hydrogens as carbons plus 2. You can see that this will hold true for all of the alkanes above. It also holds true for more complicated alkanes, even when they contain branching. Let's look at an example. Take a moment to count the carbons and hydrogens in this complicated hydrocarbon to determine its molecular formula. This hydrocarbon contains 7 carbons and 16 hydrogens. This molecular formula fits the general molecular formula of CnH2n plus 2, where n is 7. N equals 7, and 2n plus 2 equals 16. This is a useful tool to be able to tell if the molecular formula given is that of a saturated alkane. And we will look at this again when we talk about NMR and determining structure later in the semester.